Hi, this is Adam Cankaya in July 2025, showing off some of the AI improvements I've made to my R notebook that is attempting to replicate a bladder cancer paper. What I did was I took my whole Git repository and I provided it to ChatGPT, which actually now is built into GitHub, and I made a query to it asking to try to improve my code, focusing on bugs and improvements for speed and reliability. And it provided me this output of approximately 10 different items to improve. And I've implemented most of them, and it has made my code a lot more stable, less ability to crash, and less junk being output as unnecessary. Um, and so I'm going to show off what I've done in the code with the suggestions, and we'll go from there. So basically, it gave the ChatGPT gave, let's see, 9 total fixes, and then a bunch of miscellaneous speed improvements. So, for example, a lot of the speed improvements are just not unnecessarily trying to reinstall packages, those type of things. So, for example, this repeated installation of packages, I went ahead and I put in these if statements so that if a package is already installed, it doesn't try to install it again, for example. This is a bug fix. I was using 2 different variable names. Instead, I should just use a single variable name. So, for example, I went ahead and renamed all the LIHC res variables to the BLCA res variable, just so that's consistent throughout the code. We don't have 2 different variable names representing the same object. And then going through here, these are just some small bug fixes. I was misspelling a word in the heat map code. I was using some language libraries, some functions without loading the package, without loading the library first. A lot of my time was related to saving the workspaces, small bug fixes such as making sure if we're going to access a variable or a column that we put like a try catch statements in around it so that if an error happens, it doesn't cause the whole notebook to shut down. Like here, for example, I put in a try catch around this scatter plot creation. It tries to make it. If it fails, instead of just the whole notebook fails, instead it will print out a nice warning message, error message. Um, here's an example. If the package is already installed, then it goes ahead and runs this code. If the package is not installed, it won't. This is a safety thing so that it doesn't, once again, doesn't try to run something that doesn't have the package for. And then it recommended some use of these accessor functions instead of using the old-fashioned @ or $ to access columns. As far as the speed improvements go, um, it's trying to recommend basically as much data as possible, download it in advance and save it to your local hard drive. I'm already doing that, but for a first-time user who's just downloading the code for the first time, it's still going to take a long, long time to download everything and then establish that first run. I'm only using 2 threads for my code. I did some experimenting, and for just my personal computer that I'm using, anything more than two was not really improving the speed at all. There must be some overhead with having multiple threads. So this is not something I changed beyond just leaving it at two. Parallelization, it recommended um, an ability to run parallel code if I was making lots of repeated calls, like inside a for loop, but I'm not doing that. I'm only making a few small calls, individual calls to other functions, such as this Lima pipeline, that just happens to take a long time to come back. So it's not like I can parallelize this Lima pipeline function because it's a single call to a single function. I would have to actually go into the library code itself to mess around with, and we don't want to do that. So parallelization, for at least right now in this project, is not really something that's going to help any. And then the other recommendations here are just putting in conditional plotting, conditional printing of long lists of genes and such. That is really taking up a lot of the time and space. So I did put a lot of this in. I'm removing objects from the memory when I'm done. I'm suppressing out the messages. So let's look at some of the output here. So this is my original paper or this is my original results from a few weeks ago before the ChatGPT improvements. It takes about 470 seconds to finish, and it's over 33 pages of output. Lots of stuff, a lot of unnecessary, mm, all this stuff. So then compared to this improved one, the time actually did not change any. It's still around that under 500 seconds, but it's much less output. It's only 21 pages, a lot less junk, just useful stuff. And yeah, so I think it's been useful. ChatGPT was definitely useful for identifying bugs and suggestions for improvement using the latest, uh, replacing old packages with newer packages and such. So I do think that was a success. Um, so that is a ChatGPT aspect. Now, also, we talked about before using this online resource to do the gene set analysis. So if you remember this website, instead of running the GSEA code myself, which takes a bit amount of time, let's see, it is taking more than almost a third of the time. Instead of running that myself, what you can do is take the genes that we've identified and simply paste them into here, and then this runs its own um, AI tool analysis to do the gene set analysis. So for example, I ran this earlier. These are the results I got from, I think it's the positive log FC, the output here. So these are the top 6 genes, most significant ones, and we put them in here, and we can get back an analysis of what they are individually, and then how they could potentially relate to each other. And if you look through here, I'm not going to get into the results right now, but you can see there's some overlap about, this is all bladder cancer related genes. So everything here is all related to DNA replication, fixing of damaged DNA, that type of stuff. So I initially wanted to try to implement this website directly into my R code by doing like a hackish thing where I would use some HTML tools to grab the web page and the form and insert the data and get back the response. But it really is not necessary because it's fairly easy just to manually copy the list of genes that are output and paste them in here and get the response on the website here. So yeah, so that is the Chat GPT and other AI improvements I've made so far. And I'm going to make another video next to go over my actual results that I've got. And that will pretty much be the end of the summer work for me for this particular part of my assignment. So thank you.